The Garrett ATX comes fully assembled. Simply remove it from its soft carry case and fold open the search coil. Disengage both the armrest and stem rotation lock to allow the stem to rotate. Rotate the stem and search coil to level and release the spring-loaded rotation lock to allow it to automatically re-engage. The search coil can also be locked at 90 degrees to the left or right for scanning walls and embankments. When the search coil is locked in your preferred orientation, re-engage the armrest lock. The ATX can be operated with the stems fully collapsed, fully extended, or anywhere in between. To extend the telescopic stem to the desired operating length, begin by loosening the bottom stem nut closest to the search coil. Fully extend the bottom stem and tighten the bottom stem nut. Then loosen the middle stem nut, extend the middle stem, and tighten the nut. The upper stem should be used for final adjustments to the desired operating length. The correct operating length should allow you to stand upright, no stooping forward, and swing the coil in front of you without stretching or bending. To move the armrest forward or backward, open the armrest locking lever, slide the armrest to the desired position, and lock the lever. To adjust the tension on the search coil, use a thin coin or a flathead screwdriver. Turn the screw clockwise to increase tension. When properly tightened, the search coil should maintain its position parallel to the ground while still allowing tilting during operation. Do not over-tighten. To connect the ATX headphones, remove the dust cap from the headphone connector on the back panel. Ensure the headphone connector is clean. Notice the orientation of the connector before attempting to insert it. If the detector will be submerged, be sure to lubricate the O-ring on the connector with silicone grease. Fully insert the connector until it snaps snugly into place. Slide the metal locking collar onto the threads and tighten by hand. Do not over-tighten. The on-off switch for the ATX is located on the back of the electronics housing. It is best to switch on and operate the detector outdoors and away from sources of electrical interference, such as power lines, electrical equipment and appliances, fluorescent lights, or transmitters. Immediately after the initial turn-on, listen for 1 to 4 audio beeps, indicating the charge level of the batteries. 4 beeps indicates fully charged. 1 beep and a flashing low battery warning light indicates low charge and that the battery should be replaced. During operation, the yellow low battery warning light will begin flashing when there's approximately 30 minutes of battery life remaining. In addition to the flashing LED, a brief audio alarm will sound every 60 seconds. If no beep is heard after switching the detector on, verify the batteries have been properly installed. The ATX operates with a continuous audio that responds proportionately to a target's signal strength. Large or strong signals sound loud. Small or weak signals sound faint. This enhances the ability to hear faint targets and better judge a target's size, shape, and depth. By their nature, high-performance pulse detectors are often noisier than VLF-type detectors. Therefore, some minor audio noise or chatter is normal. An experienced operator will learn how to distinguish random background noise from repeatable target signals. In motion mode, the search coil must be in motion to create a response. As a general rule, poor conductors, such as small nuggets, most jewelry, small bronze coins, or nickels, should produce a high tone followed by a low tone echo. Good conductors, such as large nuggets, copper and silver coins, or large bronze coins, should produce a low tone followed by a high tone echo. Most, but not all, iron will produce a low tone followed by a high tone echo, since to a PI detector, most iron behaves like a good conductor. In non-motion mode, the coil is not required to be moving for the ATX to produce a response. Also, targets do not produce the echo heard in motion mode. So, in non-motion mode, poor conductors produce a high tone, and good conductors produce a low tone without the echo. Target signals are visually indicated on the ATX by the upper row of LEDs. A trio of red LEDs moves from left to right in response to the increasing strength of the target. Zero signal response is indicated when there are no lighted LEDs. During adjustments, the upper row of LEDs also show the settings. The ATX has two levels of controls, primary and secondary. All primary controls, sensitivity, threshold, retune, pinpoint, frequency scan, and iron check, are indicated with white letters on the control panel. These controls are directly accessible. Secondary controls, discrimination, volume, mode, ground track, and ground balance, are indicated with red letters on the control panel. These are accessible by first pressing the shift button, which turns on the red shift LED. Secondary adjustments must be made while the shift LED is lit. Otherwise, the ATX will automatically exit the secondary shift mode and return to primary adjustments in 5 seconds. One important thing to note, when adjusting any setting, primary or secondary, the initial button press always shows the current setting. Subsequent presses must be made within 1.5 seconds in order to adjust the setting. Otherwise, the LEDs will return to showing signal strength. The ATX can detect targets in either motion mode or non-motion mode. To switch to detection mode, press and release the shift button to access the secondary controls. Press the non-motion/motion button to toggle between the two modes. Motion mode is indicated by central LEDs that quickly scan back and forth. Non-motion mode is indicated by stationary LEDs. The red shift LED must be visible to switch detection modes. Press and release the shift button again to exit secondary adjustments. Motion mode is the default setting. It is usually preferred because it is more stable and quiet, but requires the search coil to be in motion to detect targets. When in motion mode, the ATX constantly adjusts to keep the threshold tuned to a constant level. In highly mineralized ground, motion mode can also help to suppress unwanted ground signals. Non-motion mode can provide additional detection depth and allows the search coil to scan very slowly, even stationary, over targets. Non-motion mode is better at isolating targets, as target signals do not produce the audio echo, which is heard in motion mode. Non-motion mode may be less stable and noisier than motion mode, and more frequent retunes may be required to cancel audio threshold drift and other environmental changes. The more powerful non-motion mode leaves all threshold tuning to the user. In highly mineralized ground, non-motion mode may be more susceptible to ground variations, so it is even more important to use proper coil swing techniques. The use of non-motion mode requires practice and is not recommended for beginners. Operating near power lines, other detectors, fluorescent lights, or other power sources may cause interference for your ATX. To check, hold the surge coil stationary away from any metal and listen for signal interference. If noisy operation is present, use the frequency scan function to obtain the quietest operating frequency for your ATX. To perform a frequency scan, hold the surge coil away from any metal. Then press and release the frequency scan button. The surge coil must remain stationary during the entire frequency scan process, which lasts for 35 seconds, as indicated by the scanning LEDs and audio pings. Completion is indicated by a triple beep. The new setting remains in the ATX's memory until the next time this function is performed, even after power is switched off and the batteries are removed. If you have accidentally activated the frequency scan function and want to abort, press the frequency scan button again to stop the function. The setting will return to its previous value. The ATX is capable of rejecting or discriminating out certain types and sizes of targets while still detecting others. The ATX has 25 levels of discrimination. To adjust discrimination, press and release the shift button to access secondary controls. Then use the disc plus and minus buttons to adjust the discrimination to your preferred level. Zero discrimination is indicated by LED 1. Maximum discrimination is indicated by LED 13. Half-step adjustments are indicated by 2 LEDs lit simultaneously. Press and release the shift button again to exit secondary adjustments. As discrimination is increased, you gradually begin to lose targets that are poor conductors, such as saltwater and nickel. You also begin to lose very small, thin targets, such as thin coins, bits of foil, small nuggets, and thin jewelry. Large iron is the last to be discriminated. It is therefore recommended to search with the default discrimination level of 0, as indicated by the first LED. Increase discrimination if desired to eliminate certain small targets, such as pull tabs or foil, but doing so may also eliminate small desirable targets. Increased discrimination may also be used to reduce interference from highly mineralized ground. However, this should rarely be required. Increase the ATX's sensitivity setting to achieve greater detection depth and enhanced detection of small targets. Be aware, however, that increasing sensitivity can also increase the detector's susceptibility to electrical interference and other external conditions. The ATX has 13 settings for sensitivity. The default sensitivity setting is 10. Use the sensitivity plus and minus buttons to adjust to your preferred level. In general, set the sensitivity as high as possible while still achieving sufficiently stable operation. Use higher sensitivity settings when searching for very small or very deep targets. Use lower sensitivity levels in locations where the detector is behaving erratically and the erratic operation cannot be resolved with ground balance or a frequency scan. Threshold is the constant audio background hum that is added to the target response. The ATX has 25 levels of threshold adjustment. The default threshold setting is level 7. Use the threshold plus and minus buttons to adjust the threshold to your preferred level. It is recommended the threshold be set to a barely audible level, or just below, based on hearing ability and surrounding audio conditions. Faint targets may only create a small variation in the audio. Therefore, running with a high threshold level may obscure such a target signal. Setting the threshold level too low may prevent faint signals from being heard. Readjust the audio threshold level as conditions such as strong winds or surf noise affect your ability to hear the background hum at a barely audible level. The ATX's volume adjustment only affects the maximum audio level produced by a large signal and does not affect the audio level or sensitivity of a faint signal. Volume on the ATX is thus a limiter and not a gain control, thereby ensuring maximum detection of faint signals. The ATX has 25 levels of volume adjustment. The default setting is 10. To adjust audio volume, press and release the Shift button to access secondary controls. Use the volume plus and minus buttons to adjust the volume to your preferred level. Concentrations of ground mineralization can create erratic sounds or ground noise, and can reduce detector performance if the mineralization is not compensated for. The ATX has advanced ground balance capabilities to handle all ground conditions, including ironstone ground and even saltwater, without the need to switch into a special mode. It is recommended to ground balance the ATX in each new environment in order to ensure maximum detection depth. Be careful not to ground balance over a target, as you may effectively eliminate the target in most cases. To ground balance the ATX, find an area clear of metallic objects and raise the search coil about 6 inches above the ground. Press and release the Shift button to access secondary controls. Then press and hold the ground balance button and wait for the double beep to indicate the ground balance function is engaged. While continuing to hold the ground balance button, quickly bounce the search coil from 1 to 6 inches above the ground. Continue to pump the coil until the ground response is completely eliminated. Release the ground balance button and begin hunting. The first few seconds of ground balance audio allows you to hear how mineralized the ground is. Lightly mineralized ground will initially produce weak audio, while heavily mineralized ground will initially produce strong audio.